Alrighty, welcome back to game design. We're making a platformer. In the last video I made a mistake. I called this a top-down 2D game. That's for a different guide I was making. This is a platformer, a 2D platformer. So in our 2D platformer, in our previous video, we added some game objects to our game. We added this player, this enemy, and the ground. And right now, when I press play, they just fall down. They fall down because we gave them a rigid body component, so they have some physics. That's a good start. What we're going to do today is we're going to make it so that our player can move by writing a script called player controller. I'm going to start by going down to the project window in the bottom of my screen. Project window. I'm going to go to my assets folder, and I'm going to right click in my assets folder, and I'm going to create a folder. I'm going to name this folder scripts. I'm also going to move this random stuff into settings just because I don't need to see it and it's in my way. It's just random stuff. It doesn't matter what it is. So we have some art, we have some scenes, which is just this one level right now, and we have our empty scripts folder. That's great. We're going to create a new script. I'm going to open my script folder by double clicking it. I'm going to right click in my scripts folder, and I'm going to create our first script. We're going to create a mono behavior script. That's just a standard Unity script, and it just basically has some setup at the beginning that is easy to use. We need to make sure to name this player controller. And if we don't name it now, then there might be a glitch. So make sure when you first create your script, you name it player controller. I'm going to open up our empty player controller. And it's opening up right now. So we're going to make it so that when we press A or D, we move left or right. And we're going to make it so that when we press spacebar, we can jump. There is a little bit of setup we have to start with. So to begin, we're using the Unity engine. This line of code at the top is just saying, it's called what libraries we're using. It's just saying what kind of code we're using. We're using Unity engine code. That should be good for now. That's all we're using. Now we want to implement movement. My AI is trying to fill out a bunch of stuff into our player controller. We want to make it so that our player controller can move our player. To do that, we're going to have to interact with a specific component of our player object. Let's look at our player object and let's think about which component we're going to need to interact with to make our player object move around the way we want them to. If I go to my player object, I have a renderer component. This just lets me view my player object. That's hardly useful for moving him around, so that's not going to be it. I have my transform. My transform does have position information, but I don't want to just set his position to different spots. I want to add physics. I want to affect his rigid body 2D. Our rigid body 2D has things like their mass, their material, their gravity. The rigid body 2D is what allows our game object to interact with the physics system of the game. So we want to move our player object. We're going to add forces to him using the physics system. And to add forces to him using the physics system, we just need to tell the rigid body which way it is we want him to move. All that is to say, everything I just said, the whole point of what I just said, is just simply that if we're trying to write code to move our player, we need to be telling the rigid body what it is we want to happen. So our code needs to have a reference, and sorry, I should be in Visual Studio. I'm in something called Cursor. It should look pretty much the same. But our code should have some reference to the rigid body. The code that we're writing needs to know about this rigid body so that the code can tell this rigid body which way to move our character. We're going to write a line of code that says for this code to work, we require a component with the type of rigid body 2D. For this code to run, we need a rigid body 2D. We're not going to be able to have our player move around if they don't have a rigid body 2D. Now my AI is trying to autofill a bunch of other stuff, but I'm just going to put what's called a comment. If I write // in my code, I get this grayed out text, and this is a comment. Whenever I write a line of code, I'm going to say what that line of code does. Require component is a class that ensures that this component is attached to the game object. If I use require component, it means that we need to have a rigid body 2D attached to this game object. Okay, great. But that doesn't do all the work. We need what's called a reference to our rigid body 2D. We need a variable that stores a reference to our rigid body 2D. This is basically going to give the rigid body a name, and whenever we want to tell the rigid body something, we're going to call it by its name. We're going to write private rigid body 2D RB. We're going to name it RB. RB just stands for rigid body. And the capitalization matters. This is what it is. It's a rigid body 2D RB. We'll talk about what private means in a second once we get to movement. So we have a private variable called rigid body 2D, and we're going to just name it RB. Every variable is going to store some information, and it's going to have a type. So this is a variable of the type rigid body 2D, and this is its name. Its name is RB. So whenever we write RB, we'll know that RB is a rigid body 2D. Now, when we start the game, the first thing that this code needs to do in our player is it needs to set our RB variable to the player's rigid body, which we'll do by writing RB is going to be equal to get component rigid body 2D. Now, you might notice that I'm not typing this stuff out. You guys might want to pause every time I type something, and you might want to write it out yourself. I should increase the font on this potentially. I think it's fine. I think you should be able to see. Okay. Let's go to the next step. Now, when we start, we find this rigid body 2D. We assign it to our RB variable. That should be everything we need to do so that the code knows about our rigid body. Now we need to start doing movement. We need to add another variable to control our movement. We're going to create a private variable called horizontal input. We're going to name it private. It's going to be a float. Now, a float just means that it's a number that has a decimal point. A float is any number with a decimal point. It could be a whole number too. It could be 0.0, but a float is a number with a decimal point. And we're going to create a horizontal input. This number is how quickly we're going to be moving left or right. If this number is negative, we'll be moving left. If this number is positive, we'll be moving right. So let's say in a hypothetical, if this number is 1, we might be moving at full speed to the right, and if it's -1, we might be moving full speed to the left. That's how we're probably going to implement this. And then if it's something like 0.5, we're moving at half speed to the right. Or if it's -0.5, we're moving half speed to the left. That's the idea with this here. Now we need to actually set this horizontal input, which we'll do in our updates. So in our updates, we're going to need to find what the player is doing. And based on what the player is doing, meaning what buttons they're pushing on their keyboard, we should do different things. Let's think about it for a second. Okay, here's what we're going to write. We're going to say if the player presses the A key, which is going to be input dot capital I input dot get key code, no, input dot get key, and then it's going to be key code A, and yeah, that'll be fine for now. If we press the A button on our keyboard, then the horizontal input will be -1. We'll also write If we press the D key on our keyboard, then the horizontal input will be +1. I think we almost have a working movement controller, player controller. Now the last thing we need is to tell the rigid body what we're setting the input to, what we're setting the horizontal input to. So the rigid body knows what button the player is pressing, and it sets our velocity accordingly. So the last thing we're going to write is this line of code, which will tell us how much to move based on our inputs. We're going to write rb.velocity equals new vector 2 horizontal input, comma, rb.velocity.y. So what this is doing is it's setting our x velocity left and right to whatever our input is, and it's setting our y velocity up and down to whatever our y velocity already is. So it's not changing our y velocity. And that's what happens every time we update. Something to note is we're using two functions here. I'm going to call them functions. It might be a bit of an outdated word, but we have an update function, which starts at this curly brace and ends at this curly brace. The update function happens, everything in between these two curly braces happen once every frame. Every frame of our game, we're going to get an update function. Whenever the game updates, once per frame, the game is going to check if the input.getKeyCode A, meaning if the user is pressing the A key, then if this happens, then whatever's in between these next two curly braces is going to happen, then the horizontal input should equal -1. Else, if the input.getKeyCode D, then the input will equal +1. So if I'm pressing A, then do this, set the input to -1. If I'm pressing D, then do this, set the input to +1. And then finally tell the rigid body what our input is and change our velocity by that amount. That should be everything to start getting us moving. We're going to need to do a little bit more. I might change this a little bit just to make it, we'll see some glitches in a second. We're going to add a little bit to stop some glitches, but for now this should work decently well. I'm going to make sure this is saved. So I'll hit File, I'll hit Save, and I'll open Unity. And let's start, okay, I have a glitch on, so if I go to my console, I could see errors. Player controller, line 30. Oh yeah, I'm missing a semicolon here. So every line, not if statements, not functions, but actual lines of code that execute, things that happen, need to end with a semicolon, and declaring variables needs to end with a semicolon. I didn't include that, so I had an error. I'm going to save this again. And I'm going to check my Unity console will tell me if I have any errors. Some of the project files refer to an API that could change. I don't know what that means. I just told it yes, but we'll see what it does. Okay. So I have this player controller. I think it should make my player move left and right when I press A and D. Let's see what happens when I press play. I press play. My player falls down, and I'm pressing A and D on my keyboard, but my player's not moving. My player is still not moving. What did we forget to do? Oh, I know what we forgot to do. A script is another component on our game object. We need to add this script to our player's components. I'm going to click it in, and I'm going to drag it in, and now my player has a player controller script, and if I hold D on my keyboard, he moves to the right, and if I hold A on my keyboard, he moves to the left. That is awesome. That's a great start. But there's a few problems. Problem number one, he's still moving. I let go of my keyboard. I need to tell my game that if I'm not pressing any buttons, he shouldn't be moving. Problem number two is going to be a little bit more complex. It's a little less noticeable. But if I press both buttons at the same time, he moves left. When I press both buttons at the same time, I want my movements to cancel each other out. We're going to change those two things right now. We're going to make it so he stops moving when I'm letting go of my buttons. And we're going to make it so he stops moving when I'm pressing both buttons. You guys should test your movement first before you move on and make sure that you can move your character left and right. Another thing that just happened is I added my script while my game was running. Any change I make while my game is running will not be saved. Will not be saved. The change I made was I added a component to my game object. That change will not be saved because I did it while the game was being played. I need to add this component to my game object again to make sure it's here while my game is not being played. That's important. Let's make those two changes now. So what we could do is when we update, at the start of each frame, we'll just set the horizontal input to 0. Code executes from top to bottom. So at the start of each frame, the first thing that's going to happen is my horizontal movement will be 0 at the start of every single frame. Then I'll check if I'm holding A. Then I'll check if I'm holding D. Then I'll move. Then it'll be set back to 0. So if I'm not holding A and I'm not holding D, nothing will happen. So it will still be 0. One more thing I'm going to change is when I'm pressing A, my horizontal input, I'm going to write that it's plus equals -1. Actually, I'm going to write horizontal input equals the current horizontal input minus 1. And for D, I'll make it so that the horizontal input is going to equal the current horizontal input plus 1. So that'll be a little bit different. What that'll do is instead of making it so that if I'm holding left, and that's the last thing that happens, then I just move left. What'll happen instead is if I'm holding both buttons, I'll start at 0. Then if I'm holding A, my horizontal input will decrease to -1. And then if I'm holding D, my horizontal input will increase by 1, putting it back up to 0, and I won't move if I'm holding both buttons. But if I'm only holding A, then it'll just go down by 1. So I'll move to the left, -1. If I'm just holding D, it'll go up by 1. So I'll just move to the right. I'll move +1. These are the changes for our input system. Let's save that and test it and make sure that we're moving to the left and right. Let's make sure that we stop moving when we let go of our keys. And let's make sure that when we're pressing both of our keys, we stop moving as well. Hopefully we see all of that happening. And you guys should be testing it too to make sure that's happening on your games as well. I hold A, I move to the left. I let go, I stop. I hold D, I move to the right. I let go, I stop. I hold A, I hold D at the same time, and I don't stop. Now that I'm genuinely confused by. And I might have to debug it in a second, but that's an okay enough glitch. I might just leave that one there because I don't want to get too bogged down debugging it. I'm just going to look really quickly if I see an obvious reason why that would happen. Horizontal input 0. Horizontal input is -1 while I'm holding A. It's because it's only detecting one input. It's only detecting A. If I hold both of them at the same time, it can't detect that I'm holding both of them at the same time. It only knows one input. Why is that? It must be something to do with how the input manager is handled. That's okay. We're going to move on. We're not going to worry about that right now. We might fix it later because a lot of what we're doing in this update function is technically not implemented correctly, but maybe we'll fix that in a future day. Okay, so we can move left and right, but one more thing is that my character is a little slow. What I want to do is I want to be able to control how much he moves by left and right. We're going to add something called a public variable. Earlier I mentioned that we'll describe what this private means. What this private means is that it can't be changed outside of the code. It can't be accessed. That variable can't be accessed from outside of this code. But we could also make public variables that can be accessed. I'm going to create a public float. A float is a number that has a decimal. Public float, speed, and I'll set it to 10. And now I'm going to make us move not just by our horizontal input, but I'm going to multiply our horizontal input, however much we're moving by. I'm going to multiply it by our speed. Now let's test this out. So the reason we made this public, by the way, is that now when we're in Unity, Unity can see the speed variable, and I can set speed to whatever I want. I can even set speed while I'm testing my game. So I can press play, and because I wrote the word public, oh, I see this is too fast. I can click my speed. I can lower it down to 5. This is actually a good speed. I like 5. Maybe I lower it down to 2. Oh, that's too slow. Yeah, I'm definitely gonna stick with that. Maybe I want a little bit of a fast-paced game. I'll go to 6. Cool. Well, there's another issue I'm seeing with my game. I have my character, but when he walks off screen, he's just gone. I don't see him anymore. What we need to do is we need to make it so that the player follows the character around. Now in Unity, this is extremely easy. What we're going to do is we're going to take our camera. We're going to make it a child of player. A child is a game object that inherits some properties from its parent. A child is a game object that's going to define some aspects about itself based on its parent. So now the camera is a player. Now, the origin point of my world is where the camera is at 0, 0. But if I set my camera to 0, 0, 0, its origin is going to be its parent. And another really useful thing is that children will always follow their parents around. So we made our camera a child game object, and now I can't see it for some reason because my Z is 0. Okay, the Z has to be a negative number. So let me just make sure my Z is set correctly in the actual game. Okay, now my camera is a child of my player, so my camera will follow my player around no matter where he goes. Whoa, what's the spinning happening? Okay, there is another problem, is when my player spins, my camera follows my player. So if my player ever spins, if my player ever rotates, my camera rotates also, which is very, very awkward. It's a very awkward behavior, is that my camera, what I'm seeing about the world, is like spinning as my player rotates. We really don't want that. The way we're going to solve that for now is we're just going to go to player. We're going to go to their rigid body. We're going to go to constraints. And we're just going to freeze our player's rotation. That'll make it so our player can't spin. There's more elegant ways to do that, but this is pretty common. A lot of popular games, Silksong, other games, have their player rotation locked. It just makes common. It's pretty frequently a thing that happens. You don't often see your player spinning and rotating around. Now, my player can't rotate no matter what. So that camera won't be spinning around. Make sure to lock but freeze your player's rotation in their rigid body. That makes it so that no force in the universe, no matter how hard my player gets hit by anything, they cannot rotate. They will not get rotated. Okay, so we have a camera that follows our player. We have a player that could move back and forth. There's one more really important feature that we want in a platformer controller, and that is for our player to be grounded. We want our player to be grounded. No, I'm so sorry. That's gonna be next. We want our player to be able to jump. Spoiler alert. We want our player to be able to jump. We want to add a jump function to our game. Let's go back to our code, and let's start by making a new function. We talked earlier that we had a update function, and we talked earlier that we had a start function. Now we're going to create a new function called jump. We're going to create a void jump. Now this function, whenever this is called, it's going to make our character jump, and it's just going to be one line of code. We're just going to say RB, rigid body. That's the rigid body. So we're telling the rigid body to move. We're going to add force. We're going to add force. Vector2.up means in the up position. We're going to add force. And we're going to do, this doesn't super matter, but we're going to write force mode impulse. This line of code you don't need to know. It just means that the way we're delivering the force is going to be very quick and punchy. We're going to give it an impulse of force going up. We need to tell our code when to jump. So we have this jump function. Every time this jump function runs, our player will jump. We need to add one more input. We need to add one more input for if we're jumping. So after after we move left or right, just so we don't mess with this up because this is working well. So after we decide how much momentum we're going to have left or right, we'll also decide if we jump. We'll write if input that get key code down. You might notice that I'm going really fast when I code sometimes. If your AI autofills the line of code that you need, just press tab. Just press tab and it'll fill it out for you. So this is a little glitched though. You have to make sure you have the exact same curly braces and braces that I do. So for example, get key code down, that needs these parentheses outside of it. And then there's this blue parentheses here on my screen. It's going to be a different color on your screen. After the if statement needs a parentheses. And then after the if statement, we also need these curly braces. All of these things need to be in the exact same spot as mine or your code will not work. So if we press space, then we'll jump. That should be it. That should let us jump. Let's save. Let's try it and let's see what happens. I'm going to hit save. I'm going to go to Unity. And I'm going to press play. And I'm going to see if my character jumps. I press left, right to move. I press spacebar. Oh, I have a little tiny hop. I have a little tiny hop. Okay. But there's a problem with this little tiny hop. It's way too small. I'm going to add another variable the same way we did with move speed. And I'll call it jump power, maybe? I'll call it jump force. Oh, perfect. It's autofilling in jump force for me already. Jesus, this thing is smart. I'll call it public jump force. So I created a new variable called public float. Public meaning I can access it from Unity. I can change it while testing. Float meaning it can be a decimal number. Jump force is just the name of the variable. We're going to be using jump force to set how high we jump. So in our jump function, we're going to add force vector2.up times jump force. We're going to multiply the amount we're moving up by times the jump force. Now, if this is saved, we can go back to Unity. We could press play. And now let's see my jump. I press space. Whoa, that's a big jump. Okay, let me lower my jump force since it's a public variable and I can set it from this controller. I'll set it to 5. Let's try that jump. Oh, that's kind of a small jump. Let's try 7. Oh, whoops, I set it to 78 instead of 7. I meant to just set it to 7. I actually did it on purpose just so we could see this absurdly high jump. I'm coming back down, coming back down, coming back down. Okay. Let's try 7. I think 7's a good jump. But wait a second. My move speed is back to 10. And now my jump force is back to 10. What did I do wrong? Oh. Okay, so when I play the game, it's really good for testing. But I need to make sure to set these variables from the editor. I need to make sure the game is not running when I set these two variables. Now, my guy jumps great. Everything seems to be working fine. I think we're about to be done. Not really. There's going to be 15 minutes longer on this video. I can move left and right. I can hit space to jump. But there's a problem. I could hit space to jump while I'm already in the air. We're not checking anywhere if I already jumped. And we're not stopping me from jumping if I already jumped. So I could kind of fly around like Kirby. Now this could be a fun idea for a game. Maybe you do this on purpose. Sometimes the best features come from glitches. But I don't really like this for our standard 2D platformer. I don't think this makes sense for what we're trying to do. So what we'll do is we will remove the ability to jump unless we are grounded. Grounding is going to be very complicated, but let's work on it together right now. Grounding has a few steps. We're going to need to have a few variables. So we'll call these variables. I forgot to do comments. I'm going to write some comments. Let's do, whoops, what is it doing? What is it doing? Stop autofilling. We're going to do a comment. We'll say public variables. We'll do a comment and we'll say private variables. And I'll do another comment and I'll call these grounding variables. And we're going to do a public transform ground check. Now, we might recognize the word transform. This is like a rigid body. A transform is a component. It's a component. Rigid body 2D is a component. Box collider is a component. Here's our transform right here. This is our transform. This is our player transform. We're going to add another child object. I'm going to right click and I'm going to create an empty game object and I'm going to call it ground checker. I'm going to repeat that one more time, even though you can watch it back in the video. You can just go back 5 seconds and watch that step again, watch it again, watch it again. But I'm going to right click in the empty space. I'm going to create an empty game object and I'm going to rename it ground checker. And I'm going to put that in my player. I'm going to set its position to 0, 0, 0. And I'm actually going to lower the Y and I'm going to put it down by his feet. So my player's feet will let me check if I'm grounded. That's going to be my ground checker. We're going to write some code now to use the ground checker to see if we're touching the ground. So let's write that code now. We're going to create, so we have this transform ground check. When we start, I think we need to set the ground check. Okay, at the start of the update, the first thing we'll do is we'll do a new function. We'll check if we're grounded. We'll check if we're grounded. And check if we're grounded is going to be a function. So I'll go to the end of my functions and I'll make a new void check if grounded. And we will do we'll do is grounded. So is grounded is going to be a new variable we have to make. So this is going to be a private bool. So a bool means it's true or it's false. We have a new private bool. This is a variable called is grounded, and is grounded is always going to be true or it's going to be false. It could be true, it could be false. If we're touching the ground, we're going to set is grounded to be true. And if we're not touching the ground, then we want this variable to be false. Then we could check whenever we try to jump, are we touching the ground? And if that's true, if it's true that we're touching the ground, then yes, we can jump. Are we touching the ground? Oh, this is false. It's false that we're touching the ground. Then you can't jump. Sorry. Let's try that. So we'll say check if grounded. We'll say is grounded is going to equal physics 2D. No. Bad. Physics 2D dot. We're going to do an overlap circle. Okay, maybe this is what I wanted. Let's see. I'm still reading this. Layer mask dot get mask ground. Okay, that works. Okay, so ground check dot position. Yeah, this should all work. So now all we need to do is in our jump function, we'll just say if we are grounded, then we'll jump. That's all we'll say. We'll say if we're grounded, then we can jump. So in our jump function, we added a line of code to check if we are grounded. And if we are grounded, then we will do that same jump as before. So every update, I'll check if I'm grounded. If I am grounded, if I press spacebar, I'll try to jump. If I try to jump, I'll run this code. And if I am grounded, if it's true that I'm grounded, then this will run, which will make me jump. Let me think if there's anything else I'm missing before I test this. I think we're good. Oh, I see what we could do. We'll check. We'll add that variable later. We could add a variable over here for this 0.1, but let's try this for now. Let's save it. All right, I think this is not going to work the first time, but let's try it. I'm going to press play. There's going to be a few problems. Okay, now it's not letting me jump at all. Ah, perfect. It even tells me. If I go to my console, it has an error. The variable ground check of player controller has not been assigned. We created this public transform for ground check. I need to tell my code which transform it is going to be our ground checker. I need to open my player. I need to open their player controller component. I need to go to the ground check variable, and I need to click on my ground checker and drag it into this ground check variable. Now my code will know that this ground check should be referring to this object that's at the player's feet. Let's try that now. Let's see if it works now. I'm glad it shows us that error, so if a student has it, they can see in the console why their game's not running. I can move left, right. Moment of truth, I press spacebar, and nothing happens. Nothing's happening. Let me read through my code one more time and see where that problem is. So each update, I'm going to check if I'm grounded. When I check if I'm grounded, it's going to make a circle around my ground check's position of 0.1 F. That's really tiny. And it's only going to check if it's hitting layer, get mask, ground. So, okay, I see what's happening. We have two problems. For one, this is too tiny. We're going to make a variable called ground check radius. And we'll make a public float ground check radius. And we'll set it to 1. Now, we can detect the ground from 10 times as far, a lot farther away. That'll make it a lot easier to jump. And there's one more piece of code here in this is grounded line. The last piece of code checks if we're touching the ground. This is checking if this circle that's starting around the ground checker's position with a radius that's set up here, this circle's set up here, this is checking if it's touching the ground. We never set anything in our game to be the ground, though. Our last step, and then we'll be done with this lesson, and we'll see this more in the future, is we're going to set the layer of the ground. We're going to add a new layer. We're going to call this layer ground. Now I can go to the ground object. I can click layer, and I can set it to ground. We'll only be able to jump if we're touching the ground. Let's try it now. Now I actually do suspect that it will actually work. And if it doesn't, I'll be a little bummed out, but let's try it. Boom, I jump. When I'm pressing spacebar in the air, I can't jump. That is our full movement. When I'm standing on top of this enemy, I can't jump on his head because he is not the ground. Oh, and I see. This is funny too. My ground, I can jump from way too far away from the ground. So I can jump when I'm on the ground, but it detects the ground from way too far away. My radius that we just made is too big now. Ground check radius, let's make it 0.1 again. Let's try that. Okay, now that is working great. Let's actually keep our ground check radius at 0.1. And that's the full lesson. Now you guys can start adding different code. You know what we'll say actually? You know what we'll say? We'll add one more thing. We'll add a death mechanic. I'm just going to make it so when I die, I go back to the origin point. So I'll just say update. At the end of my update, the last thing that'll happen is if my transform dot position dot y is less than -20, then my transform dot position will be 0, 0, 0, 0. I'll move back to 0. I'll move back to the origin point of the game. Let's try that for resetting our character if we die or fall off the map. And now I think that's all you guys need to start building out your game. Now you can maybe start building a simple platformer just by adding more platforms. When I fall off the map, I respawn back up here. Next time, we'll give it, we'll make some enemies that can maybe do some simple things. Maybe they chase you. Maybe they have colliders that hurt you. And maybe we'll add some details. Maybe we'll add some art, make our character move back and forth, make him animated a little bit. We'll see what we want to add. It's totally open-ended, but this is a great start. Now, if I wanted to, like if you have some free time today, you could start adding 2D object, sprites, square, and you can start kind of blocking out how you might want your level to look. You should make sure if you're copying these from each other, layer should be ground, and now I can make a bunch of copies of these. I'm also going to set the color actually. Let's give it a better color. Art assets. Oh, I don't have any materials. How did I color this then? I colored it in its renderer? Okay, that makes sense. I'll color this renderer too. And so if you have these platforms, you can control C to copy them. Once you set the color, the ground, whatever you want. And you could start building out a little prototype level. We're going to replace these with art assets probably, or maybe we could just cover them up with art assets and have these be your actual level itself. But let's test my little thing. I just put some platforms. So now, oh, they're not solid. Oh, that's a mistake. I didn't give them colliders. I should add component, and I should give them collider, box collider 2D. And I can stretch these out while I'm placing them. I can shrink them down. And I'm placing them all willy-nilly, but you really want every part of your level design to be really handcrafted, very intentional. Intentionality is like one of the most important things you can have. I'm getting body blocked by this NPC. I can't get by. Maybe that's his job. Maybe he's the body blocker NPC. I'm just going to set him to be ground, which is a little bit cheating, just so I can get by. So I can jump off his head now that he's the ground. I made this level too... Okay, let's move that out of the way. Oh man, okay, let's lower this a little bit. And the sad part is, I'm testing this now, but when I unpause my game, all the level design I'm doing is going to get undone. So, it's just part of the struggles though. Okay, that was a really fun video. That's going to be it for me. That will be all of our work for the week. And it's going to be very difficult, but hopefully everybody can get this working.